Okay, question 7 involves an integration, and we've got a fraction, so what I'd like there to be is for the top to be the differential of the bottom, or some multiple of, in which case it would be a log, but it's not that. I'm then looking to see if the bottom will factorise, because then I know it'll be partial fractions. It's not that either. Therefore my next approach is going to be to complete the square at the bottom. So I complete the square, I get x minus 5 squared. 5 squared is 25 plus 9 dx. Now what I'm looking for now on the former sheet is these here. So I'm looking for this one here, arctan, because I've got a square plus something. It could be an artanch if I had 1 minus, and I've also got to bear these two in mind, but I've got no roots involved in this one. So I'm looking for the arctan, but I need to get it in the form 1 plus something squared. Okay, so clearly that 9 is an issue. So if I take the factor 9 out, so I put a ninth here, and then I'm going to have 1 over, let's move the 9 to the front so it's the right format. 9 times 1 is 9, obviously, and here I get x minus 5 over 3 squared dx. Okay, purely because the 3 squared gives me the 9 again. Now I think what I'm going to do is I want the limits from 8 to 5. I'm going to do a substitution at this point, just because it's quite easy to get confused with the fractions. So I'm going to let y equal x minus 5 over 3. If I differentiate it, dy by dx equals a third. That implies 3 dy replaces the dx. I've also got to replace the limits rather than change it back again at the end. So if x equals 8, then y is 8 take away 5 is 1, and if x equals 5, then y equals 0. So now by the change of variable, I've now changed the integration into this. So it's between 1 and 0, and I've got a ninth, and I've got the integral of 1 over 1 plus y squared times 3 dy. Okay, clearly I can take the 3 out, so I end up with a third integral 1 to 0, 1 over 1 plus y squared dy. Now I know the integral 1 over 1 plus y squared, that's arctan. Okay, so I've got that equals a third tan to the minus 1, or arctan if you prefer, of y. And I'm going to do that between the limits of 1 and 0. Arctan of 1 is pi by 4, so it's a third. That'll be pi by 4. Arctan of 0 is 0, so it equals pi by 12. Okay, 7b, very similar, but this time we've got a square root at the bottom. Our approach is going to be broadly similar, same starting point, but if you remember from the formula book, if I can bring it across, we're now, last time we were looking for this time we're looking for arcshine, okay, because of the square root. But our approach is broadly similar, so let's get going. So I'm going to complete the square, same as last time. X minus 5 squared plus 9 dx. Now remember, don't want a 9, I want a 1. So I'm going to take a 9 out. I'll do it in 2 steps, but you probably could do it with 1. 1 over square root of 9 x minus 5 over 3 squared plus 1. Okay, and then because it's a root 9, it becomes a third when I bring it out. Okay, I probably could have missed this step out, but I'm taking a factor of 9 out, but it's a factor of root 9. Okay, and 8 and 5. So it's similar to last time, except last time I had a 9th at the beginning here. Root x minus 5 over 3 squared plus 1. Again, I'm going to do a substitution. I'm going to use u this time, but let u equals x minus 5 over 3. The change of variable, same as last time, x equals 8, u equals 1, and x equals 5, u equals 0. I differentiate it. Du by dx will equal a third, which implies, same as last time, move the dx and the 3, so 3 du replaces the dx. Okay, now plug those back in again. I'm going to get the integral of between 1 and 0. 1 over root u squared plus 1 du. Now remember, I had a third at the front and I've got a 3 du, so third, so this 3 here and this third here will cancel. I could put a third times 3 there, but it's not really necessary. Okay, now I know from the formula sheet that that is r shine of x, or u in this case, and it's between 1 and 0. Now the r shine is also on the formula sheet. If you look just above it over here, we know r shine x equals this, and we want it in logs, so that's perfect. Okay, so let's move it across a bit. So I've got so I want r shine 1 take away r shine 0. So put 1 in place of x in here, and I get log of 1 plus root 1 squared take away 1, which is 0. Then I put 0 in, I get log, oh sorry, I get r shine, apologies, I get log 1 plus root x squared plus 1, sorry, this is 2 here. Rub it out, and do that bit again. So that's log, because I'm using r shine, it's this one here. Okay, I want x, which is 1, plus root of 1 squared plus 1, which is root 2. And then I do r shine of 0, put 0 in, I get log of 0 plus 0 squared plus 1 is 1. Log of 1 is 0, so I end up with the answer of log 1 plus root 2. Out of the way. So I've got it in the right form. Log of 1 plus root 2, a is 1, that is root 2.